In this video I'm going to show you my remote control setup for my Go2 dog. I've made a setup in Home Assistant that I can start it remotely using an ESP32 circuit. And here you can see it starting up. Later in the video I will show you in a little bit more detail how I have set this up. But for now it's first a demonstration on how it works. Legion on GitHub has created a very nice WebRTC UI repository which you can use to remote control the robot via Wi-Fi. When the web server is running, it's really easy to connect. With the later firmware you need an AIS key to connect to it. I'll show you later how you can obtain that key. And then you have a similar interface as you have with the app on your phone. It works the same way. In the settings here you can, if you have an Xbox controller or another controller hooked up via USB, you have to press a button for the browser to recognize the controller, and then as you can see here the text shows and you can enable it. And my LiDAR is giving some issues, so I always disable obstacle detection because that doesn't work very well anymore. And you can change the color of the LED. And then you can control it remotely using that controller. That works better because you have analog controls which give you a little bit more control over it than using on-screen joysticks. There is of course quite a lot of lag because you're doing this over a network connection. So it's a bit finicky to get the robot around in such a small area. Unfortunately I don't have a pro version though, so I cannot use the SLAM data to have it navigate automatically. That's for a next project. So for now it's a bit finicky to get it back to the docking station to get it aligned properly, but it always works, just go slow. And the docking station is really a simple thing. It's just two aluminium plates that I've glued to this wooden plate, and I put 32 volts on it, and that makes it work. I've connected the power supply to a smart plug, which is also available in Home Assistant, which I can turn on and off to charge the robot. The robot has to be on for it to work, because if the robot is powered off and you apply power, then the robot starts up and starts to stand up, which disconnects the whole setup. So before turning off the robot I need to turn off the power supply, and then I can click the button for the ESP32 for the robot shutdown sequence to start, and then the robot will shut down eventually. So I've used an ESP32 module that I use to power a relay, which then presses the button on the battery of the Go2. To make this unit last for a while, I use deep sleep. So this ESP32 has a cycle of 5 minutes deep sleep, and then it powers up again to see if a button was enabled in Home Assistant. If no, it goes back into deep sleep. If yes, then it will run the startup sequence. And that way I have about 3 weeks of battery life on this system. And that's all. This is all mounted to the back of the robot. So here you can see the ESP32 module. That needs to have its own power, of course. So that's why I have those two batteries connected to it. So it gets 3 volts uploaded to 5 volts, and that goes to this cable, which is connected to the battery housing. It's magnetic, so it's easy to unplug. And basically what it does is press the power button in a similar way that you would manually do to start up the robot. I've also added a remote control unit for radio RC control. And I've added the emergency button for the e-stop, which is also available via Home Assistant via another ESP32 board, which basically does the same thing. It just connects two contacts together. Legion has this GitHub repository. It's very easy to install, as you can see here. And for a normal setup on Linux, I use both Ubuntu or WSL on Windows. And here you can see all the commands that I use to set up the environment and to install all the dependencies and everything. The errors I got with Pi audio are listed here as well, and how to solve it. And then to get it to work, you need to get an AES key, and this is the command to get that from your Unitree account. My robot is from China, so I had to add the region CN at the end, and then you get this AES key, which you can use in the UI to connect to the robot. And then it's just a matter of cloning the repository, install it with npm, and then it works. Next step is to make the robot more autonomous using the SLAM LiDAR data. Unfortunately, I don't have a Go2 Pro, so I have to do it a little bit more manual. So I'm going to add a Raspberry Pi to it and then use the cloud point data to make something more autonomous for it to work. So that's next. So keep an eye on this channel. When I have it working, I will post a new video. But it can take a while, so be patient. And I'll see you in the next video. Bye.